Welcome students, hope you're all fine. Look at these integral equations. This is definite integral from pi over 6 to pi over 3. 1 minus cosine squared x over sine squared x dx. So here we can use an identity of trigonometry. As you know, we have a famous identity, sine squared x plus cosine squared x equals 1. Here we can move this to the side, so it will be sine squared x equals, keep 1, minus cosine squared x. Now we can replace this by this one. Why? Because 1 minus cosine squared x is equal to sine squared x. So rewriting our integral as, keep this one, 1 minus cosine squared x is sine squared x dx. Now we can cancel this with this, so it will be 1 over 1. So it will be pi over, it will be 1 dx. Integral of 1 is just 1 and this variable, 1 times x. So it will be 1x, but not plus c, because it's definite. A half bracket from pi over 6 to pi over 3. Now, opening two brackets, we replace each x by pi over 3 first. So replace x by pi over 3 and put it in the first bracket. And replace x by pi over 6 and put it in the second bracket. Now it's pi over 3 minus pi over 6. We have different denominators, so we can make them the same. Multiply by 2, multiply by 2. Because 2 divided by 2 is 1, like I did nothing. So 3 times 2 is 6, 6, 6, so it will be 2 pi over 6 minus pi over 6 equals 2 pi minus pi is 1 pi over 6, and this is the answer. What about this one? This is involving exponential, natural exponential, and len. Before solving this one, we have a property of len. Property of len. It says if I have len x to the power of a, this will be, we can move this a ahead of this len and we can put it here. So it will be a len x. But what if I have a len x? We can make it len x to the power of a. So len x to the power of a can be a len x, and a len x can be len x to the power of a. So we can move this back above x. We can make it exponent for x. Here I can do the same here. I have 5 len x, so I can make it len x to the power of 5. Why? In order to cancel e and len, but in this way I cannot cancel e and len. If you are canceling e and len and 5x, the answer is 5x. This is wrong, because I have a number here. That's why I'm going to rewrite this one. This is not the integral. This is just rewriting the expression. So we can write this as e to the power of len x to the power of 5, based on this property. Based on this property. And the same thing can be done here. E to the power, we can move this for len x e to the power of len x to the power of 4. And the same thing here, e to the power of len x to the power of 3 plus e to the power of len x to the power of 2 and dx. Now I can do the cancellation. I can cancel e and len E and lim, E and lim, E and lim. Once again, rewrite this one. So it will be x to the power 5 plus x to the power 4 over x to the power 3 plus x to the power 2 dx. Finding GCMF, greatest common monomial factor. Since I have x common in both, here the same, so it will be just x to the power 4 x plus 1, x to the power 3 x plus 1 dx. Here I can take 2 x's out, not 3 x's. Because x squared times x cubed, x squared times 1, x squared. Now I can cancel this factor with this factor because they are the same. And we have 4 x's here, we have 2 x's. I can cancel these 2 x's with 2 x's. So we have left with 2 x's. So it will be just x to the power of 2 dx. And integral of x to the power of 2 is x to the power of 3 over 3 plus c, because it's indefinite integral. We have to add c to the result. This can be written as, this is the answer, but in case you did not see this among the options, so I can write this as 1 over 3 x to the power of 3 plus c, and this is the answer. What about this one, tan squared x? Do we have a specific rule for integrating tan x squared or tan squared x? No. But we have something like this. This is a reminder. If I have integral 1 plus tan squared x dx, this will be just tan x. But 1 is missing here. I have tan squared x, but I don't have 1. But I can add 1, but not only adding 1 without having other things with 1. So here I can say tan squared x plus 1 and minus 1. Why? Because positive 1, negative 1 is 0. Like I added the whole expression by 0. Or I add 0 to the whole expression. When you are adding 0 to the whole expression, nothing has been changed. Which means I can write or rewrite this one as tan squared x plus 1 minus 1 dx. If you cancel this and this, you will get back to this once again. That's why, like I did nothing, positive 1, negative 1 is 0. But here we need this one. Why? Because we have a specific rule for this. Tan squared x plus 1 is just tan x. This is the integrating tan squared x plus 1. What about this negative 1? This is constant. Integral of constant is constant times x. Now we have to use integration for each one. I can distribute the integration over this bracket because we have addition and subtraction. So this will be integration tan squared x plus 1 dx plus minus integration, since I have minus here, integration of 1 dx. This is also dx. Integration of tan squared x plus 1 is tan x minus integration of 1 dx is just 1x. And it's indefinite, so plus. And this is the answer. What about this one? Here I have tan squared x plus 9. We don't need 9, we need 1. But I can make 9 as 1 plus 8. Because 1 plus 8 is 9. And tan squared x plus 1 is just tan x. Integrating tan squared x plus 1 is tan x. So I can rewrite this as tan squared x plus 1 plus 8. Why plus 1? Because we need 1. If I have 1 with tan squared x, I can get the integral and dx. Now we can integrate each one separately. Integral of tan squared x plus 1 is just tan x. Integral of a is 8x plus c, and that's it. Thanks.